Welcome to this explainer. I am so incredibly excited to take you through today's topic. In my line of work as a software researcher, I literally spend my life digging through endless lines of code. But today, I'm taking you with me inside a genuinely fascinating, completely invisible cyber war. We're talking about a relentless, high-stakes battle between game developers trying to lock down their creations and elite hackers who are absolutely determined to break them wide open. We're going to look at the code, the cracks, and the ultimate frontier, the cloud. So let's just dive right in and see exactly how this digital arms race has evolved over the decades.
To really get why this is so crazy, picture this. It's 2009. Ubisoft drops Assassin's Creed 2 with a massive, very public challenge to the world. They essentially wanted to end game piracy forever. To pull this off, they rolled out a brand new, wildly expensive system called Always Online Protection. The idea was simple but brutal. Every single player had to be connected to Ubisoft servers every single second they were playing. Internet drops, boom, game pauses. They proudly paraded this around as uncrackable protection. But, well, as any software researcher will tell you, waving a red flag like that at the internet is a very, very dangerous game. Within exactly 24 hours, that supposedly uncrackable server was completely emulated, bypassed, and effectively deleted. Millions of dollars spent on defense and cutting-edge encryption just evaporated. Defeated by an invisible army in a single day. So how on earth does that actually happen?
To make sense of how games actually get cracked, we need to map out this crazy chronological arms race. We'll start with the golden age of keygens, move into digital guards and fake servers, face the boss fight known as Denuvo, look at reverse engineering the code, and finally explore the uncrackable cloud horizon.
All right, part 1, the golden age of keygens.
Let's rewind the clock back to the 1990s. Security back then was honestly pretty quaint compared to the absolute behemoths we have today. When you look at the timeline, you see this crazy rapid escalation from physical ownership to pure digital licensing. In the 90s, we basically relied on simple CD keys, those little strings of letters and numbers printed on the back of the chunky game manuals. If you had the box, you had the code. Have the code, you legally own the game. But as things evolved from physical disks to always online demands and now to cloud gaming, you're literally watching the industry desperately trying to plug the holes hackers kept punching in their boat.
See, the fundamental flaw with 90s security was that games weren't actually phoning home to some server to check if you swiped your credit card. They were just checking if the math of the CD key made sense. It was a completely offline algorithmic check. So what did the crackers do? They built keygens. As a researcher, I actually find keygens kind of beautiful in their simplicity. They're just little programs that reverse engineer the game's mathematical logic to spit out infinite, perfectly valid CD keys. The hackers basically just copied the developer's math homework, and it ended up costing the gaming industry millions. That's when the gloves really came off.
Moving on to part 2, digital guards and fake servers.
By the early 2000s, the industry realized that simple math wasn't going to save them. They started fighting back with physical checks, things like SafeDisk and SecuROM, demanding literal proof that a physical CD was spinning in your drive. But hackers just bypassed that by tricking the computer with fake virtual drives. Easy. So developers needed a much heavier weapon. Enter DRM, or Digital Rights Management. I want you to think of DRM like a super paranoid security guard that actually follows you around inside the video game. It's always watching, it never trusts you, and it's constantly checking your ID against a VIP list on a remote server. It's constantly asking, hey, did this user actually buy this? If the server says yes, the DRM lets you play. This constant validation loop, that's exactly the engine running under major platforms like Steam and Epic Games today.
But here's where it gets really clever. Notice the totally different approach here. The developer's weapon relies on a real server asking that vital question. Did he pay? The hacker's bypass. They didn't try to fight the server, they just intercepted the call. They built fake servers directly inside the user's own computer that perfectly mimicked the real deal. So when the game nervously asks its security question, the hacker's code casually steps in and replies, oh, for sure, yes, he's a total VIP. The game swallows the lie completely and just opens the front door.
Which brings us to part 3, the boss fight, Denuvo. To combat those fake local servers, the gaming industry unleashed an absolute monster of encryption, Denuvo. You have to understand why Denuvo was such a total nightmare for hackers. Unlike normal DRM that might just check your status once at the main menu, Denuvo encrypts the game dynamically, constantly shifting while it's actively running. And even crazier, it creates a unique, highly specific digital fingerprint tied directly to your exact hardware setup. It maps out your specific machine. If you just pop in a new stick of RAM, or honestly sometimes even just run a standard Windows update, Denuvo notices the shift and might completely lock you out. And you know what? For years, it worked. The elite hacking scene actually went dead silent. For a long time, Denuvo seemed literally unbeatable.
Okay, part 4, reverse engineering the code.
But as we know, the war in the shadows never truly stops. The elite hackers just adapted. They brought out the big guns. Incredibly advanced reverse engineering software, specifically stuff like IDA Pro. Now, if you're a casual gamer, you might not have heard of it. But in the software research world, IDA Pro is legendary. Crackers use it to literally freeze a game at the exact microsecond it tries to talk to the Denuvo servers. In that frozen moment, they pop the hood and look at the raw code instructions. Right when the game's code gets ready to ask, "Is this user valid?" the hackers surgically alter the code. They rewrite the instruction to simply say, "Don't ask, just run." They don't fake the answer anymore, they just delete the question.
And please, scratch the image of a lone rogue programmer in a dark basement. That's a movie myth. Behind every major cracked game is a highly organized elite underground syndicate. We're talking groups with names like Reloaded, Core, and CPI. They treat this like a AAA software development cycle. One specialist will strictly study the code architecture. A different engineer builds the complex crack, and an entirely separate QA team rigorously tests it across dozens of different computer setups to make sure it bypasses Denuvo's hardware check for everybody. It is a wildly coordinated operation.
Actually, I love this little detour. Amidst all this hyper-serious cyber warfare, developers occasionally show a brilliant sense of humor. Sometimes they use what's called fade protection. Instead of just crashing the game if a crack is detected, they let the pirate keep playing, but they completely sabotage the experience from the inside. The most famous example is Grand Theft Auto 4. If the game realized it was pirated, it basically made the in-game camera drunk. It would violently sway and shake, rendering the entire game dizzying and totally unplayable. It's such a hilarious and brilliantly frustrating trap.
Finally, Part 5, the uncrackable cloud horizon.
Eventually, the industry had to face a hard truth. As long as local code is sitting on a user's PC, it will always be vulnerable. Someone can freeze it, analyze it, and eventually break it. So, they made a massive paradigm shift: cloud gaming. Modern games are slowly migrating to a model where the gameplay is rendered safely in a heavily guarded remote data center. All the crucial calculations that used to happen on your physical machine, they're now happening on a corporate server hundreds of miles away. To crack a cloud game, hackers can't just mess with their own computers anymore. They would have to literally hack into a massive corporation's private servers. So, for the first time in gaming history, the industry might have actually found a genuinely uncrackable defense.
So what does this all mean for us? As we wrap up this explainer and look back at this relentless, decades-long arms race, we're left staring at a really provocative philosophy from the hackers themselves. Because as games vanish into the cloud and digital licensing completely replaces physical media, we have to ask a profound question about digital ownership. The cracking community operates under a very specific, highly controversial ethos. They argue that if buying a digital game just means renting temporary access to a remote server, if buying isn't truly owning, then maybe, just maybe, piracy isn't actually stealing. It's a complex debate for sure, but it's the exact ideological fuel driving this invisible army forward. Thank you so much for joining me on this deep dive into the code. I really hope this gave you a brand new perspective on the invisible wars raging behind your favorite games.